Hey everyone, welcome back to my channel. Today we are going to continue talking about set operations, but first I've got a little something to unwrap, so let's do that. Okay, so this is a birthday present from my brother and my sister-in-law. Aren't they nice? So let's set it up and see how it works. Okay, let's just adjust that and we're set up. So that looks pretty good. Let's start talking about some complements and differences. Let's look at their definitions and we'll also look at a couple of example problems.
So let's look at some more ways to construct new sets out of old sets. And the next way is what's called the complement, and we write it with this superscript C here. So A superscript C. What does that mean? That means the complement of A. And let's look at the definition. So the complement of A is any element X, again from the universe, such that X is not in A. So you could imagine the complement of A is like the negation of A, or the reverse of A. So let's look at an example. Say I have a set A, right? And it's in our universe. We've got it in our universe U. Straighten it up into a nice rectangle for us. So this is our universe U, and the set A is inside U. Well, what would be the complement of A? The complement of A would be anything in the universe which is not in A. So it would be the region outside A. So any part of the universe which is outside the boundaries of A. Okay, so that will complement. This shaded region would be the complement. Okay, let's look at the next one. The next one is what's called the difference. We have A minus B here. So what does that mean? So A minus B is the set of elements X such that X is in A but not in B. X is in A and X is not in B. So you could imagine it as saying, you know, give me all the elements of A, but none of the B's, even if the B is also an A. So let's look at a Venn diagram to make it a little more clear. So here's A. The difference, A minus B, it will be the region of A which is not overlapping with B. So this would be the region which contains elements of A but not B. Now we do not include the intersection. We don't include the region where A and B overlap. A minus B is the region of A which excludes all the B members.
Okay, so the most important thing we need to know are the definitions of complement and difference. So the complement of a set is all the elements outside the set. So the complement of A contains every element that's not in A. The definition of difference, so A minus B, that means give me all the elements of A, but don't give me any of the elements in B, even if the B's are A's. So it's all the A's that are not B's. Okay, so with those definitions in mind, let's look at a variation on the question from the last video, but looking at complements and differences.
So again, we have the intervals X and Y. X is 4 to 6, including 6 but not 4. And Y is 6 to 8, including 6 but not 8. And now we want to find the difference between X and Y and the complement of X. So let's draw the number line again. So let's say it goes 2, 3, 4. Okay, and the intervals are the same as before. So we had the interval X, which didn't include 4, but did include 6. And we had the interval Y, which included 6, and didn't include 8, so that's Y. So the first thing would be, what is the difference? So X minus Y would be all the regions of X that don't include Y. So let's say that I want to go to store X, but I can't go there when Y is open, because if I go there when Y is open, the store owner of Y will come out and yell at me or something like that. So the difference would be, what time is X open but Y is not open? Okay, so it would be all the region of X that doesn't include 6, because at 6, Y is open as well. So it would be that interval there, excluding 6. Okay, so the left boundary would be the same as X. So it would be starting at 4, but not including 4. And then it would go all the way to 6, but not include 6. So the next one is, what is the complement of X? So the complement of X is any region outside of X. So let's say that I want to go down to the stores, but I don't want to go when X is open, because when X is open, you know, I get too tempted and I buy all the candy at X, and, you know, that's not a good situation. So I only want to go down to the shopping mall when X is closed. So let's try and find the interval when X is closed. So it will be all this interval, right? It will be everything up until 4, because X only opens at 4. And it will include 4, because remember, X is not open at 4. The interval X starts at 4, but it doesn't include 4. So 4 will be included in the complement. Okay, and then X is open until 6. So we can't go there for between 4 and 6. But X closes at 6. And we can see that the interval X does include 6, right? It does include 6 because this square brackets and we've got a closed circle here. So the complement of X will not include 6. So we cannot go at 6, but we can go anytime after 6. Okay, so let's think of how to write this. Let's do this interval first. So that interval goes all the way back. It goes 0, -1, -2, and so on and so on and so on. So it goes all the way to -infinity. Okay, and then it goes up until 4, including 4, because X doesn't include 4. And the complement of X has to include everything that X doesn't include. Okay, that's the first interval. And then the second interval, it starts at 6 but doesn't include 6. It doesn't include 6 because X includes 6. And then it goes all the way to infinity, right? Because this goes 10, 11, 12, blah, 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 until infinity. Okay, so we've got 2 intervals here. And the complement of X is going to be the total area that these 2 intervals cover. And how do we write down the total area? We use the union symbol. So the complement of X will be the interval from -infinity up until 4, including 4, union the interval between 6 and infinity, not including 6.
Okay, so that's sorted. So far, we've just been looking at examples using intervals of continuous regions on a number line. Let's look at some intersections, unions, complements, differences of sets that are discrete, so sets that aren't over intervals. And let's see if there are any differences or similarities.
This time we have some discrete sets. We've got A and B. A and B are both sets of faces, and the faces are drawn from the set U. So U is the universe, so this is our universe of possible faces. Okay, so the first one asks us to find A union B. Now all of these we can just basically write in the set roster notation. Okay, so A union B, so this will be any face which is in either A or B. Okay, so all we need to do is just list all the faces that are either in A or in B. So we've got the cool face, the sunglasses, the mouth. We've got the smiley face here. So checked off that. We've got the smiley face. We've got the angel. We've got the frowny. Okay, so we've done all the elements of A. What else have we got? We've got the stern face with the straight mouth, very stern. Now, the angel is already there because the angel was in A, so angel is already accounted for. And then we've got two of the same face. So we know that repeats don't count in a set, so we can just get rid of the second one and just use the first one. And so the first one is the toothy smile. Ugh. Okay, that one. That's the sound I'm imagining him making. Okay, let's do the next one. So A intersect B. So these will be any faces which are in both sets. Okay, so I can only see one. I can only see the angel. So the intersection, that will be just the set containing the angel. Now we want A minus B. So A minus B will be all the elements of A which are not in B. So it'll be all the elements of A except for the elements which are in the intersection of A and B. So that will be all the elements of A except the angel. Okay, so it will be sunglasses. Oh, sorry, cool. It'll be smiley. Right, so we got sunglasses, smiley. We don't have the angel because angel is in B, and we want the difference, and then the frowny. So the frowny face. Okay, so that's A minus B, all the elements of A that aren't in B. And finally, we have the complement of A. Okay, so the complement of A will be all the elements in the universe, right? All the elements in the universe which are not in A. Okay, so let's just go through the universe. We've got the angel. The angel is in A, so it won't include that one. Cool is also in A, so we won't include that one. Frowny also in A. Smiley also in A. So a lot of them are in A right now. Sterny, okay, Sterny is in the universe, but not in A. So this will be in the complement of A. Sterny. Okay, good. And then the last one is Toothy. So Toothy is in the universe, but it's not in A, so it will be in the complement of A. Okay, so that's the complement of A, Sterny and Toothy. Should we call him Toothy? Smiley? Toothy. Let's call him Toothy.
Okay, that's it from me for this video. So let me know if you got any questions, put them down in the comments. Also let me know if you want me to cover any particular topics in future videos. And yeah, remember to like and subscribe. Thank you so much for watching.